This is my geometry course. Today we're going to prepare for part 2 of the final test. This test is going to cover the second half of the course, everything after test number 3. As usual, we're going to do a practice test right now together, and I'm going to give you a practice test for homework. The practice tests are not optional, they're mandatory. You cannot pass the test without studying, and that's the purpose, as I've mentioned before, these practice tests is to force you to do a little bit of studying. It's especially important to study for these final tests because they're cumulative. They're covering everything in the course. So it's going to take you quite a while to prepare for the exam. I would say at least 3 days. You're going to have to go back and look at everything in the course. When you approach a final exam or any kind of exam in any course, your studying intensifies, and that's especially true when it comes to cumulative tests. So a lot of students complain they don't want to have to go over and learn everything, but that's just the way it is. Just be aware that most of the things in this course you're familiar with at this point. So you don't have to go back and do every single problem. You only have to do the problems where you're not sure that you can find the correct answer. So you may only have to look over maybe 50% of the material or 40% or whatever. Go back to that material in the description section of the videos. Click on the time code where it says screenshots of the classwork. Go back over the homework, so on and so forth. So as usual, I want you to attempt these problems on this practice test, version 1, before watching me do them. That way you can make sure that you're thinking about the problem and your mind is engaged. So try part 1 of number 1, and when you come back, we'll do it together. Okay, we're back. Notice that these arc measures are equal. And those arc measures are created by these chords. So we learned a theorem that says that if you have two chords that create these arcs, and the arcs are congruent, then the lengths of the chords must be equal. So that means that GH must be equal to 6 inches because FE is 6 inches. So if you got that one right, good job. That was an easy one. They are going to get harder. Try part 2. When you come back, we'll do it together. All right, we're back. So we have a central angle, and how do I know it's a central angle? Well, because we're told up here this is circle K. So that means that this point here is the center, and it's the vertex of this angle. So that's a central angle. And the corresponding arc created by the central angle, its measure is 88 degrees. So by definition, it's very important to understand that this is by definition, meaning mathematicians just decided this is the way it's going to be. The central angle is also going to be 88 degrees. So the measure of angle AKB is equal to 88 degrees. Make sure you write your degree symbol. Now, there are reasons that mathematicians have defined this arc measure to be equal to the corresponding central angle measure. It's not exactly obvious why they do that, but just be aware that this is not a measure of length. 88 degrees does not measure the actual length. There's a difference between arc measure and arc length. Arc length is the actual distance along that yellow line there. All right, try part 1 of number 2. When you come back, we'll do it together. All right, we're back. So remember, you can use SOHCAHTOA to remember. I don't know if I went over that in class, but sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. I'm just using this because I don't want to write out the sine, cosine, tangent stuff. So we're trying to find sine B Sine is opposite over hypotenuse. So you look at angle B, find the opposite side, which is 3, and divide by the hypotenuse, which is 5. Now, how do I know that 5 is the hypotenuse? Well, because it's the longest side of the right triangle, and it's opposite the right angle. Remember, sine, cosine, and tangent, those trig ratios, they only work for right triangles. Very important to understand. If this were not a right triangle, then we couldn't find sine B. Unless we had other information. Go ahead and try part 2. If you got part 1 right, good job. And when you come back, we'll do it together. All right, we're back. So we're not allowed to use a calculator for this particular problem. If you use a calculator, you would have to round off because it would be a decimal. We want the exact answer. So how do we do this? Well, notice they're looking for cosine 45. So that's a 45-degree angle. So remember, we have a theorem. It's called the 45, 45, 90-degree triangle theorem, something like that, that tells us that if these angles are 45 and this angle is 90, and you know that this side is W, then that means this side must also be W, and this side is W times root 2. That's the theorem. Now, why do we care about that? Well, cosine 45 degrees, again, if you use your SOHCAHTOA, we see that we have cosine here. Cosine is adjacent over hypotenuse. So we can use either one of these angles. You'll get the same answer. If we use the bottom angle, then the adjacent side is omega and the hypotenuse is omega root 2. So again, cosine is adjacent over hypotenuse. So adjacent over hypotenuse. And now it doesn't matter how big or small the triangle is, these numbers are going to cancel out because it's a ratio. So we end up with 1 over root 2. Again, the w's, they cancel. But remember, we're not allowed to leave a root in the denominator. We need to rationalize the denominator. So we're going to multiply both sides by root 2. 1 times root 2 is root 2. And root 2 times root 2, well, that's the same as squaring. When you multiply something by itself, you're squaring it. That's the opposite of square rooting, so it just gets rid of the square root. If you want to review how to rationalize denominators, you can go to my beginning algebra course. We don't really have time to do that now, but if you got that answer, good job. And yes, you must change it into this form. You cannot leave it in this form. On to number 3. Go ahead and try number 3. When you come back, we'll do it together. All right, we're back. A plane is flying at an elevation of 8,000 feet. The angle of depression from the plane to a person on the ground is 32 degrees. What is the distance of the shortest route from the plane to the person? So we could use this triangle or this triangle. I'm going to use the top triangle. So I'm going to go down here and draw that. Your triangle doesn't have to be perfect. We know that this angle is 32 degrees. And it's very important to understand that this distance over here in our triangle, this distance over here is the same as the elevation. So that length is 8,000 on that side, and we're looking for the shortest route. That means if this person could fly, the shortest distance to the plane would be that hypotenuse of the triangle. So we're looking for x here. And of course, that's a right triangle. If it were not a right triangle, we wouldn't be able to use the method we're about to use with our trigonometry, sine, cosine, or tangent. So we're given the opposite side of the angle, 32 degrees. We're given the opposite side, and we're looking for the hypotenuse. So which trigonometric ratio uses or is defined with the numbers for the hypotenuse and the opposite side? Well, that's sine. So sine 32 degrees is equal to the opposite side over the hypotenuse. And there's a lot of different ways to solve this equation. Students typically have a lot of problems with these types of equations, but rather than get all confused and frustrated, just solve it. Just get it done fast. My first instinct is to get rid of the fraction. We don't like fractions in equations. And to do that, you multiply by x, because 8,000 is divided by x. So if you multiply by x, you're going to get rid of that x. And that's going to turn this situation into something much more easy to deal with. So notice that our yellow x's canceled out. So now we don't have a fraction anymore, but we still need to get x by itself. So now what we're going to do, and you don't have to show all this work, by the way. I'm just doing this for your benefit. We divide both sides by sine 32, and now x is equal to 8,000 over sine 32 degrees. And we're going to use the calculator to come up with an approximation for what that would be. So in your calculator, you can enter 8,000, then divided by 32, then the sign button, then equals. If you don't push the equal button, then you're not going to get your actual answer. So now we have 15,096. And notice that this problem does not tell you what you should round off to. So that means that we're allowed to determine for ourselves what we're going to round to. And I'm just going to round to the nearest whole number. You must write your units. If you don't write feet, then you're going to lose points. So 15,097 feet. If you got that answer, good job. All right, on to number 4. Go ahead and try number 4. When you come back, we'll do it together. All right, we're back. If the line containing segment AC is tangent to circle B at C, find the measure of angle C. So what that means is that the line that goes through AC, it touches the circle only once at C. So that's what it means to be tangent. And we learned a theorem that says that if AC is tangent to the circle, then that means this angle here must be 90 degrees, because this is obviously a radius. How do we know it's a radius? Well, because it says circle B. That means that B is the center, and obviously this segment here goes to the side of the circle. So whenever you have a radius connecting a tangent, this angle must be 90 degrees. So this problem was a very easy problem. There's not really any work that you need to show. Now, you may have to deal with a problem similar to this where you do have to show some work, so that just happened to be a fairly easy one. If you got that one right, good job. Try number 5, and when you come back, we'll do it together. All right, we're back. Notice that these are exterior angles. They're not interior angles of the polygon. We learned a theorem that says that it doesn't matter how many sides you have in a polygon, the exterior angles of that polygon, whether it be a hexagon or pentagon or octagon, it could have a million sides to it. The exterior angles are always going to add up to 360 degrees. So what that means is 120 plus 60 plus y plus 90, that's a 90-degree angle because it's a box, must be equal to 360. And again, it doesn't matter if it's a quadrilateral in this case, or a pentagon, or hexagon, or septagon, or octagon, or nonagon. It doesn't matter. The exterior angles are always going to add up to 360 degrees. So we're going to add these angles together, and we get 270. Subtract 270 from both sides, and we get 90 degrees. So y is equal to 90 degrees. If you got that one right, good job. Try part 2 of number 5, and when you come back, we'll do it together. All right, we're back. This is an inscribed angle. How do we know that? Well, because the vertex is actually on the circle. And an inscribed angle creates a corresponding arc. Now, we learned a theorem that says that this angle is half the arc measure, half of the measure of the corresponding arc. So the measure of angle DAC is equal to 164 divided by 2, and it's as simple as that. So that would be 82 degrees. If you got that one right, good job. So you may notice that some of these problems are fairly easy, and they are, but they may get, these problems are going to get more difficult. So, all right, number 6. If the number below is the sum of the interior angles of a convex polygon, how many sides does the polygon have? Try number 6, and when you come back, we'll do it together. All right, we're back. We learned a theorem that says the sum of the interior angles in a convex polygon is equal to 180 times the number of sides of the polygon minus 2. Now, we're told that the sum of the angles is 2,340. So we can just enter that in, and all we have to do is solve for n in this problem. Now, the easiest way to do this problem is to divide both sides of this equation by 180. This 180 will cancel out, but students typically don't do it that way. They use distribution, so I'm just going to solve it the way most students would. Use distribution. So 180 times n is 180n, and 180 times negative 2 is negative 360. And by the way, you can try dividing both sides by 180. See if you want to do it that way, then go ahead and do it. So now we're going to add 360 to both sides, and we get 2700 is equal to 180n, and then we're going to divide both sides by 180, and we get 15. So the number of sides of the polygon is 15. It has 15 sides. So if you got that answer, good job. On to number 7. Go ahead and try number 7. When you come back, we'll do it together. All right, we're back. Find the unknown values in the parallelogram below. So we're told that this is a parallelogram. Now, we learned a theorem that says that opposite sides of parallelograms are congruent. So if this side is 47, that means that k must be 47. So I'm going to start with part 2. So k is 47 inches. And we also have a theorem that says that opposite angles are always congruent. So if that angle is 85, then that means x must be 85 degrees. And we have another theorem that says that consecutive angles, angles next to each other, are supplementary. So if we know that x is 85, and by the way, we could use these two angles also. We know that this angle is 85, so 85 degrees plus b must be equal to 180. That's what it means to be supplementary. So then subtract 85 from both sides of the equation, and we get 95 degrees. So b must be 95 degrees. Now again, opposite sides are congruent. That was the first thing that we mentioned. So that means that 3a minus 3 must be equal to 30. And if you solve, it's a two-step equation. Add 3 to both sides, divide by 3, you get 11. So if you got 11, good job. And I don't require you to write units for this because a was just a number inside the expression. Some teachers may require you to write units. I don't really care. It's kind of a weird issue to consider. On to number 8. Go ahead and try number 8. When you come back, we'll do it together. All right, we're back. So we're told that this is an isosceles trapezoid. That's very important. That means that these sides must be congruent. So x, we can say immediately, is 20 meters. Now, you must write your units. If you don't put an m there, then you're going to lose points. Now, we learned a theorem that says that if a trapezoid is isosceles, then that means that the base angles must be congruent. So these two angles are base angles, and these two angles down here are base angles. And by the way, these sides are called legs. The legs in an isosceles triangle are defined to be congruent. But if this angle is 110, that means this angle must be 110 also. Again, the base angles in isosceles trapezoids are congruent. And we also learned that consecutive angles in an isosceles trapezoid are supplementary. That's another theorem. Again, you can go back to our lessons on trapezoids. This is all in the classwork that we did. Go to the description code, click on the time code where it says take screenshots of class work. So that means that 110 degrees plus z must be equal to 180. Again, this angle plus this angle must be 180 because we learned a theorem that says that consecutive angles in trapezoids are supplementary. Subtract 110 from both sides, and we see that z must be equal to 70 degrees. So if you got that one right, good job. All right, so now we're dealing with a kite. Tells us that shape down there is a kite. And we learned a theorem that says that the angles between non-congruent sides are congruent. So beta must be equal to 99 degrees. That's pretty easy. And in order to find omega, we'll use the fact that the sum of all the angles in a convex polygon is equal to 180 times the number of sides minus 2. Now, we know the number of sides. It's a quadrilateral, so that's 4 minus 2. You don't really have to show this work, but I'm just demonstrating how we know that all the angles inside that polygon must add up to 360 degrees. So now that we know that the sum is 360, we can make an equation. 360 is equal to 93 plus 99 plus beta, which we found is 99, plus omega, and I'll just move that equation down a little bit. And if we add these numbers up, 99 plus 99 is 198. 198 plus 93 is 291. And don't be afraid to use your calculator to do that. Subtract 291 from both sides, and we get 69 degrees. So if you got that one right, good job. It's good to look your work over. Don't move to the next problem too quickly. Want to make sure that all that looks right, and it does. So now we're on to the next problem. Okay, try number 9. When you come back, we'll do it together. All right, we're back. This is a rhombus, and remember, rhombuses are defined as quadrilaterals with all sides congruent. So if this side is 27 centimeters long, then K must be 27 centimeters. So that was an easy one. I started with part 3 there. We also learned a theorem that says that the diagonals, those orange segments, they must be perpendicular, which means that beta must be 90 degrees. We also learned a theorem that says that the diagonals in a rhombus create 4 congruent right triangles. So this triangle, this green triangle here, that triangle must be congruent to this blue triangle. So corresponding parts of congruent triangles are congruent. So if this angle is 42, this angle must be 42 also. There's not really a lot of work you have to show for that. So if you got those answers, good job. On to part 4. If you haven't done part 4 yet, go ahead and try that. When you come back, we'll do it together. All right, we're back. So this yellow segment here is a mid-segment of the trapezoid. Now remember, you can have a mid-segment of a triangle or a mid-segment of a trapezoid. How do I know that this is the mid-segment? Because the problem doesn't tell us that it's the mid-segment. I know because we have double tick marks here and double tick marks here. That means that it bisects this leg of the trapezoid over here. And I have single tick mark here and a single tick mark here. That means it bisects the other leg also. That's the definition of a mid-segment. It's a segment that bisects the legs of a trapezoid. And its endpoints are actually on the legs. But we learned a theorem that says the length of the midsegment, this is the midsegment theorem, the length of the midsegment is equal to the sum of the bases divided by 2. So now all we have to do is solve, multiply both sides by 2, and we get 34 is equal to x plus 20. Subtract 20 from both sides, and we see x is equal to 14 feet. So there you go. If you got that one right, good job. All right. On to number 10. I'm going to make this a little bigger because we've got plenty of room. Go ahead and try number 10. And when you come back, we'll do it together. All right, we're back. Write the equation of the circle below. Now remember, the standard form of the equation of a circle looks like the following. Sorry, that should be minus h. R is the radius, and notice that this is not the radius, this is the radius squared. And h and k are the coordinates of the center of the circle. So all we have to do is look at this picture, find the radius and the center, h and k, and then we can plug those numbers in. So we can see just by looking at this circle that that orange dot there, that's the center, because if you count 1, 2, 3, 4 up, you get to the top of the circle, and if you count 1, 2, 3, 4 to the right, you get to the right of the circle, and so on and so forth. And so that point is -2, -2, and maybe I should write that in. -2, -2. So I can plug in -2 for h, and I can plug in -2 for k. Now r we found is 4. That's the distance from the center to the sides of the circle, and that's obviously 4 units. So we plug in 4, and those are double negatives, so they become positives. And if you square 4, you get 16, and that's it. It's as simple as that. So if you got that one right, good job. All right, on to number 11. Go ahead and try number 11. When you come back, we'll do it together. Okay, is the following polygon an acute, obtuse, or right triangle? So we learned something called the Pythagorean inequalities theorem that says that if the square of the longest side of a triangle is less than, we don't know yet, so we're going to write a bubble. If it's less than the sum of the squares of the other two sides, then it's an acute triangle. If it's greater than, if this square here is greater than the sum of the squares here, then it's an obtuse triangle. And if these values end up being equal to each other, then it's a right triangle. So if you square a square root, you just get rid of the square root. We're left with 119. And then we have 81 plus 36. And 81 plus 36 is 117. So we see that this value is greater than, so we can write a greater than symbol there, which means that it's actually an obtuse triangle. Now, what does that mean to be an obtuse triangle? That means that this angle here is actually greater than 90. So an obtuse triangle has one angle that is greater than 90 degrees. If you got that right, good job. Try part 2 of number 11. When you come back, we'll do it together. All right, we're back. We have a right triangle, and it's flipped so that it's sitting on the hypotenuse, and we drew an altitude down here, and that altitude cut the hypotenuse to make two segments, a yellow and a blue segment. So this is in our studies of right triangles. I believe it was the first class on right triangles. And we learned a theorem that tells us in this situation, the leg length is equal to the geometric mean of the side, or the segment closest to that leg, times the sum of those segment lengths created by the hypotenuse. Now I know that that seems really complicated, but it's just a matter of memorizing the formula. You either memorize the formula or you don't. That's up to you. I cannot force you to use your brain and memorize that formula. A lot of students say, oh, I can't memorize it. Yes, you can, and yes, you will. Get it done. Your brain is capable of about 10,000 times more than you realize that it is. And that's not a motivational speech, that's just a fact. Kids, by the time they reach 7 or 8 years old, they already know 3,000 words in the English language. If you can learn 3,000 words, then you can easily learn, a few formulas. Now, there are a lot of formulas in this course, but it's nothing compared to 3,000 words. Now, you're not allowed to leave that in the root as 80 because there's a perfect square. Now, the best way to do this is to factor to 16 times 5. 16 times 5 is 80. The 16 comes out, and the 5 stays in. When the 16 comes out, it becomes 4, because when you square root 16, that's 4. Now, again, a lot of students are going to look at that, and they're going to think, I don't know where you came up with that. Well, you can go back to my beginning algebra course, where we talk about how to pull out perfect squares. It's in the square root part of the course, radicals, something, some title like that. So if you got that answer, good job. Go ahead and try number 12. When you come back, we'll do it together. All right, we're back. So the easiest part of this is actually to find AB. I'm going to do that first. We learned a theorem that says that if you have a point outside of a circle and you draw a tangent to the circle, meaning it only touches one place, and another tangent on the other side of the circle, the length of those segments, the lengths are equal. So AB must be 37 feet. So that was a very easy part of the problem. Now the measure of angle CDB, this angle here, we can't find that angle because we don't have enough information. We have this angle, but we don't have these angles. But recall, we learned in a previous part of this practice exam that if you have a tangent connected to a radius, and that's obviously a radius, because we're told the segments are radii, then this angle and this angle, they're both 90 degrees. And it turns out that this shape is a kite. We don't really need to know that it's a kite, though. So 90 degrees plus 90 degrees plus 42 degrees plus the measure of angle CDB is equal to 360 degrees. We learned that the sum of the angles in a quadrilateral is always equal to 360. We did 2 problems. Actually, I think we did 1 problem that showed that, so we don't really need to show that again. Add these up, you get 222 degrees plus the measure of angle CDB is equal to 360. Subtract 222 from both sides, and we get 138. So if you got 138 degrees, good job. On to part 3 of this problem. Go ahead and try part 3. When you come back, we'll do it together. Okay, we're back. PQ, segment PQ, is a diameter of circle K. So what that means is that this arc measure here is just going to be 180 degrees, because that represents half the arc measure of the circle. Remember, total rotation is 360 degrees, so the arc measure is defined to be 360 degrees for a circle. So from here to here we have 180, and if you add this little extra part here, you find that that's the remaining part of the circle. If the blue arc measure is 135, and we know that the central angle is 135 degrees, that's what this is telling us. Therefore, the blue corresponding arc measure must also be 135. This measure here must be 135, so we can just subtract 135 from 360 to get the yellow arc measure, which is what we're looking for. So 360 minus 135 is equal to 225 degrees. Then they ask for the measure of angle PKQ. So that's a central angle because K is at the vertex. That's this angle here. Now, again, this arc measure is 180, so the central angle is also defined to be 180. Remember, the measure of the central angle is defined to be equal to the measure of the corresponding arc. So it's 180 degrees. So some of these problems, as you can see, if you know what you're doing, they're actually very easy. If you got those answers, good job. On to number 13. Try 13. When you come back, we'll do it together. Okay, if K is the center of the circle below, find the arc length. That's what that symbol means. Find the arc length of arc AB. So we learned that the arc length, I'm just going to call it S, arc length is equal to the central angle divided by 360 times the total circumference of the circle. Now, we don't want the total circumference of the circle. We don't want the total length. We just want this length here. That's why we're multiplying by this fraction. So theta is 47, and the radius is 8. And at this point, you can just use your calculator to approximate the answer. 47 divided by 360 equals, then times 2 equals, then times pi equals, and then times 8 equals. So we have 6.56, and it doesn't tell us what to round off to, so we can just round to the nearest hundredth place. And the units are centimeters. So if you got that one right, good job. Okay, on to number 14. Go ahead and try 14. When you come back, we'll do it together. All right, we're back. Find the measure of arc AB if K is the center. Now, we learned that inscribed angle theorem that tells us that if we know this inscribed angle with the vertex on the circle is equal to 38, then the corresponding arc measure must be double that. And we also know that because this segment goes through K and it hits the sides of the circle, that must be a diameter. So the total arc measure from A to C is 180 degrees. So what we need to do is take 180 degrees and subtract. We're going to take the whole yellow length there, and we're going to subtract 2 times 38, which would be this length here. And so we have 180 minus 76, which is equal to 104 degrees. If you got that one right, good job. Go ahead and try part 2 if you haven't already attempted that problem. When you come back, we'll do it together. All right, we're back. Is BC, segment BC, a diameter? We learned a theorem that says that if a chord in a circle is a perpendicular bisector of another chord, then that first chord must be a diameter of the circle. Now, we know that this chord is perpendicular to the other chord because of that red box, but we don't know it's bisecting this chord because we don't have any information about this yellow length and this blue length. So that means there's not enough information. So if you got that one right, good job. It might be a diameter, but we don't know. Okay, on to number 15. Try part 1 of number 15. When you come back, we'll do it together. Okay, we learned a theorem that says that if you have 2 intersecting chords in a circle, the angle, and there's actually 4 angles created, but we can consider any angle. This is the one in question here. So that angle must be equal to the sum of the arc measures that were created by those intersecting chords divided by 2. Multiply both sides by 2, and we get 174 is equal to 63 plus the measure of arc AB. Subtract 63 from both sides, and we get 111 degrees is equal to the measure of arc AB. So if you got that one right, good job. All right, on to part 2. Go ahead and try part 2. Part 2 is going to be a little tricky. This problem can be tends to stump students, so give it your best shot. If you get stuck, that's okay. When you come back, we'll do it together. Okay, we're back. So we're trying to find AC, the length of AC, the segment AC, the chord. But we don't really know any information here about this chord, so how do we do this? Well, there's a theorem that tells us that if a radius is perpendicular to a chord in a circle, then it bisects the chord. That means that this blue length will be equal to this yellow length. So it is perpendicular because we see that square right there. So we know that this length is equal to this length, but we still don't know either of those lengths, so how are we going to find the length of segment AC? Well, we know that sorry, my computer's going kind of slow. We know that this length is 3, and we know that this length is 2. So if we add those two up, we get 5. So the radius of the circle must be equal to 5. That's useful information. If we know the radius, then that means the distance from here to that point must be 5 also, because we're going from the center to the side of the circle, just like this segment here goes from the center to the side of the circle. These are both radii. So at that point, I'm going to take this triangle out and analyze it, this yellow triangle, and that's going to help us find the length of AC. So I'm going to draw a triangle over here. Doesn't have to be the exact same shape. We're just using this for reference. So we know this side is 3. This is B and P and C. And we know that this side is 5, because remember the radius, this length here, PC, is 5. It's the same length as this radius here. The radii all have the same length. So now you can see where we're going with this. We're going to use the Pythagorean theorem. BC squared plus 3 squared is equal to 5 squared. And you can already see this is going to be a Pythagorean triplet, which means that the side lengths are going to be whole numbers. Square root both sides, and you don't really have to show the actual symbol square rooting because it's obvious what's going on here. But BC is equal to plus or minus 16, or 4. But remember, a side length is not allowed to be a negative number, so it's just going to be 4. Now, a lot of students would stop there and go on to the next problem, but we're not looking for BC. We're looking for AC. Now, because this radius is perpendicular to the chord, that means it bisects the chord. So if BC is 4, that means that AB must be 4 also. So AC is just 4 plus 4. So AC is AB plus BC, obviously, and AB is 4, and BC is 4. So AC is 8. If you got that answer, good job. Okay, on to number 16. Actually, we're part 3 of 15. Go ahead and attempt part 3. When you come back, we'll do it together. Okay, we're back. So we have two intersecting chords, and we learned a theorem that says that the product of the two segments in one chord is equal to the product of the two segments created in the other chord. And if we divide, 5 goes into 64 12 times with a remainder of 4, so it's going to be 12.8. But don't be afraid to use your calculator in that problem. All right, part 4, it says find x if r is the center. We learned a theorem that says that if two chords have the same length, then they must be equidistant from the center of the circle. So the yellow length and the blue length are equal. So x plus 6 must be equal to 2x plus 11. Subtract x from both sides, subtract 11 from both sides, and we see x must be equal to negative 5. Now, it's true that a length cannot be equal to a negative number, but if you plug in negative 5 into x, you see that the lengths are not negative numbers, so be aware of that. Try number 16, and when you come back, we'll do it together. Okay, we're back. We learned a theorem that says that if you have two secants, these are secant number 1 and secant number 2, because they hit the circle twice. Tangents hit the circle once, secants hit the circle twice. If you have two secants coming from a common point outside the circle, the product of the outside length in one secant and the sum of the total length of the segment is equal to the same thing in the other secant. Now this is where a calculator is going to come in handy here. We can just add those numbers up. 6 plus 3.8 is 9.8. And we're going to distribute 5 times 5 is 25, and 5 times y is 5y. And 6 times 98, or 6 times 9.8 is 58.8. And if you subtract 25 from both sides, you get 33.8. Divide both sides by 5, and we have 6.76. So if you got that one right, good job. Again, don't be afraid to use your calculator. All right, on to part 2. If you haven't tried part 2, go and attempt that. When you come back, we'll do it together. All right, we're back. We have two tangents here because they touch the circle once. And we learned a theorem that says that the angle created by the tangents extending from that common point outside the circle, the angle measure is equal to the difference of the arcs that are created divided by 2. So 204 minus 156 is 48. And 48 divided by 2 is 24. So there you go. If you got that answer right, good job. On to number 17. Find the area of each shaded region below. Attempt part 1 of 17, and when you come back, we'll do it together. Okay, we're back. So we have two shapes here. We have a rectangle, this rectangle here, and we have a triangle. So we need to do some detective work. We can first write that the area of the shaded region is equal to the area of the rectangle plus the area of the triangle. The area of the rectangle, that's going to be pretty easy. Area of a rectangle is length times width, and we see the length is 8. Tells us over here it's 8, and the width at the very top it says is 4. So that's going to be 4 times 8. And the area of the triangle is base times height divided by 2. Remember, the area of any triangle is always base times height divided by 2. So we need to do some detective work to figure out the base of this triangle. The base is this length here. It's an upside down triangle. We know that this length is 2 centimeters, and this length is 2 centimeters. And we know that this length up here is 4, so we can just extend that down. So 2 plus 4 plus 2 is 8. So the base of the triangle is 8. So 1/2 times 8, and then we just need the height. The height of the triangle is the distance from here to here. Now again, we need to do some detective work. We know the total distance from here to here is 12, and the distance from here to here is 8. So just subtract, and that'll give us this light blue distance here, which we're looking for. So 12 minus 8 is 4. And I'm going to go ahead and write that so we can see where we came up with that. So then we end up with 32 plus 1/2 times 8 times 4, and that simplifies to 48. And remember to write your units. We're talking about area here, so this is going to be not centimeters, but square centimeters. So if you got that one right, good job. Go ahead and try part 2 if you haven't already attempted that problem. When you come back, we'll do it together. All right, we're back. So we're looking for that shaded area. So we're going to find the total area of this rectangle. And I probably should have said assume that these are right angles. So I'm going to enter those in. A lot of times when you see problems like this, you're just supposed to assume it's a square, and it's probably okay to do that. But technically you should have those little squares there, so we know it's a rectangle. So we're going to find the total area of the rectangle, and then subtract the area of the kite, this area here. So the area of the shaded region is equal to the area of the rectangle minus the area of the kite. The area of the rectangle is obviously 7 times 12, length times width. The area of the kite is 1/2 times the product of the diagonals. And you can see that this diagonal length, this blue diagonal length, is equal to 12. And the other diagonal length is equal to 7. Now again, where do we find all these formulas? Well, they're in the you can find a link in the description section. It says take screenshots of class work, and you can find all these formulas. So we have 84 minus 42, which is 42 square meters. Again, be sure to write square meters because we're finding area. So that's the area. That's a measure of the area in the green shaded region. If you got that one right, good job. Go ahead and try number 18. When you come back, we'll do it together. Okay, we're back. So let's say that you have a raindrop that's going to fall in this region. And let's say that this region inside the figure is the entire universe. The raindrops cannot fall anywhere outside of this universe. What is the probability, assuming that the raindrops fall randomly, what is the probability that a raindrop is going to fall in that purple area? So we need to find the probability, and that is the area of the shaded region divided by the total area of the whole figure. So the area of the shaded region, that's going to be pretty easy. That's just the area of the triangle. So the base of the triangle is 20, and the height is 30. So that's very easy. So 1/2 base times height. Okay, now we need to find the area of everything inside this figure. Now we have a rectangle. We'll find the area of this rectangle. The area of the rectangle is just length times width, so that's 30 times 20. So we need to find the area of the rectangle first. Then we need to add the area of this semicircle and this semicircle also. And again, it's kind of assumed that those are semicircles. Sometimes you'll have a note that says these are semicircles, but sometimes you'll have problems where they won't tell you that. Now, we can't find the area of a semicircle. It's impossible, unless you have the radius. Now, the radius is a distance from here to here, so that's going to be 1/2 of 20. So we'll add pi r squared, and 1/2 of 20 is 10. But remember, we want to find the area of a semicircle, so we have to divide that by 2. So pi 10 squared divided by 2 is the area of that bottom semicircle. But we still haven't found the area of this semicircle here. Now, we know that this total distance here is 30, so that means the radius is going to be 1/2 that, 15. So again, we just add pi r squared, radius being 15, divided by 2 because it's a semicircle. So those are a lot of numbers. Again, the problems are getting a little more difficult now. Let's see if we can simplify. 1/2 times 20 is 10. 10 times 30 is 300. So that was pretty easy to simplify the numerator. 30 times 20 is 600. And 10 squared is 100. And then 100 divided by 2 is 50. So we have 50 pi. That was pretty easy to simplify. Here we have 225 divided by 2, and that's not going to be an easy number, so I'm just going to leave it. Actually, I think I'll change it to pi, a multiple of pi. So 15 squared is 225, and then divided by 2 is 112.5 pi. Now you can do this in parts. And in this problem, I'm going to say round to the nearest thousandth. In this problem, I should probably tell you what to round to. All right. So we can add those pi's in the bottom. So 112.5 pi plus 50 pi is equal to 162.5 pi. And like I said, you can just enter these numbers in, and add them up. But you're going to want your answer to be correct to 3 decimal places, because we're rounding off to the nearest thousandth. So I'm going to enter 162.5 and then times the pi button. Be sure to use your pi button, equals, and then plus 600 equals. All right, so that's the bottom. It's 1,110.5088, so on and so forth. So you can enter that. I'm going to find some more room here. So that is the denominator, 1,110.5088. And I don't really have a lot of room here, so I'm just going to take 300 and divide it by that. And we get 0.2701. 0.27, and we're supposed to round to the nearest thousandth, so that's going to be our answer. So if you got that one right, good job. Now we should write a squiggly equal sign, because that's approximately equal to 0.27. So if you got that one right, good job. Okay, on to number 19. Go ahead and attempt number 19. When you come back, we'll do it together. Okay, we're back. The ratio of corresponding sides, i.e. the scale factor, of 2 similar solids is written below. Given the volume of the larger solid, find the volume of the smaller solid. So we learned a theorem called the proportional volumes theorem that tells us that if 2 solids are similar, then the ratio of their volumes is equal to the cube of the scale factor. Now the scale factor, we're told, is 1/4, so we can just plug that in. Now notice that the bigger number, we have a 1 and we have a 4. The bigger number is on the bottom. So we're given the volume of the larger solid. Because the bigger number is on the bottom in your scale factor, the bigger number has to be in the bottom when it comes to your volume ratio. The bigger number is 3 because, again, we're told that that's the volume of the larger solid. And we're supposed to be finding the volume of the smaller solid, which is the top one here. And I'll just keep calling that V1. So 1/4 times 1/4 times 1/4, what would that be? 1 times 1 times 1 is 1, 4 times 4 times 4 is 64. Multiply both sides by 3, and we get 3 over 64. Make sure to write your units. We have cubic inches. So why is it that 1 over 64 times 3 is 3 over 64? Well, remember, write your whole number as 3 over 1, multiply straight across. That's something that you should know by now. If you got that answer, good job. On to number 20. Go and attempt number 20. And when you come back, we'll do it together. All right, we're back. Write a paragraph proof to show that if the quadrilateral ABCD below is a square, then it's a rectangle. So if this is a square, prove that it's a rectangle. So we'll start with the given information. It is given that ABCD is a square. Well, we should probably start a new sentence. By the definition, of a square, angle A, angle B, angle C, and angle D, all the angles must be right angles. Square is defined that way. A square is a quadrilateral with 4 right angles, and the sides are all congruent. Then we can say, by the definition, of a rectangle ABCD must be a rectangle, because a rectangle is defined to be a quadrilateral with 4 right angles, but we showed by the definition of a square that this quadrilateral has 4 right angles. So by the definition of a rectangle, I should put a comma there, ABCD must be a rectangle. So you may have different variations of the grammar and whatnot, but as long as your sentences make sense and they're complete sentences, then good job. Okay, on to 21. Go ahead and try 21. When you come back, we'll do it together. Okay, we're back. Find the surface area of the figures below. We learned that the surface area of a sphere is equal to 4 pi r squared, and r is 6. And at that point, you can just enter into your calculator, but we know that 6 squared is 36, and 36 times 4 is 144. So that makes it a little easier for us to enter that into our calculator. So the area is equal to 144 times pi. Use the pi button on your calculator, and we get 452.389. It says to round to the nearest thousandth up there. And the units are square centimeters. We're looking for the area, so make sure it's square centimeters, not cubic centimeters. Now we're going to find the surface area of a cone. And it's assumed in this picture that this green dotted segment there is the height. Again, you're going to see that in a lot of problems. It's assumed that this is a vertical segment, but technically there should be a box there. So we know that the surface area of a cone is equal to the area of the base, which is a circle, so it's pi r squared. Let's assume that that's a circle in the base, plus pi times the radius of the circle times the slant height, which we'll call L. So the radius of that circle is 8, half of 16. So plug in 8 for the radiuses. Sorry, my pen is kind of malfunctioning. And the slant height we actually don't know. So in order to figure that out, we're going to have to move this stuff down. And we're going to have to make a right triangle. And we're going to find the slant height, which is this blue length here, using those given numbers. So I'm going to rewrite that triangle out here. Again, your triangle doesn't have to be the exact right lengths. Half of 16 is 8, and so we can use the Pythagorean theorem. 15 squared plus 8 squared is equal to x squared. We get 225 plus 64, and we get 289 is equal to x squared, square root both sides, and we get 17. I guess I can show the square rooting. I don't really care if you show the square rooting at this point, to be honest with you. It's assumed that you know how to do that. But you may be a little rusty because we haven't, it's been a while since beginning algebra. But remember, a length cannot be equal to, sorry I keep moving this down, a length cannot be equal to a negative number. So that's going to be positive 17. So that is the, and I probably should have called that L. That is the slant height of the cone. So now, if you want, we can just enter those numbers in your calculator, or we can combine these multiples of pi. 8 times 17 is 136. This just makes it a little easier to enter this in your calculator. And we get the area is equal to 200 times pi. Now if you enter into your calculator, it's pretty easy. So 200 times the pi button equals, and A is approximately equal to 628.319. And it says to round off to the nearest thousandth, and that's going to be square millimeters. So we got that one right. Good job. On to number 22. Try number 22. When you come back, we'll do it together. All right, we're back. It says find the volume of the following solids. If necessary, write your answers as multiples of pi or round to the nearest tenth. So this is a right cylinder. The volume of a right cylinder is the area of the base times the height of the cylinder. And the radius is half of 3, which is 1.5. And the height is 4. So at that point, we can just use our calculator. So I'm going to enter pi times 1.5, then the square button, then equals, then times 4 equals. Now that's how you would enter it into an iPhone, but if you're using an Android or we're going to round to the nearest 10, so it's going to be 28.3. If you're using an Android or a Texas Instrument or graphing calculator, you may not enter it in that order. So 28.3 cubic meters. Make sure you write cubic meters because we're finding volume. All right, on to part 2. To find the volume of that solid, we need to find the volume of the rectangular prism at the bottom. And then the volume of the pyramid at the top. So the volume of a rectangular prism is just length times width times height. I'm going to go ahead and write that out. Volume of a pyramid is 1/3 times the base area times the height. And notice that those heights are different. So the length is 10, the width is 7, and the height is 3. It doesn't really matter what you name those because of the commutative property of multiplication. The base of the pyramid is a rectangle, and the width is 7, and the length is 10. So remember, the area of a rectangle is length times width. So we have 7 times 10, and the height is 6. That's this length up here. So multiplying, we get 210 plus 140. And that's going to be 350 cubic millimeters. So if you got that one right, good job. Okay, go ahead and try 23. When you come back, we'll do it together. Okay, we're back. So we need to find the area of this little green segment there. Now remember, that area or that space in there captured by the chord and the circle, that's called a segment. But we also use that word for the normal segment with endpoints, like so. So just be aware that the name is used for both things. So what we're going to do is we're going to find the area of the total sector, which is this whole area here, everything, including the green part and the triangle. We're going to find the area of that sector, and then we're going to subtract the area of the triangle, and that's going to give us the green shaded area. So I'm going to say part A, the area of the sector is equal to the central angle divided by 360 times the area of the whole circle. So theta is 45, and the radius is 2 root 2. Now, you could enter all that into your calculator, but it's going to be pretty easy for us to reduce that fraction there. And 2 root 2 times 2 root 2 is going to be 8. But you can enter all this into your calculator. Just be aware that there is room for mistakes. The more you have to enter into your calculator, the greater the chance that you're going to enter it in incorrectly. But we end up with 1/8 times 8 is just 1, so that's going to end up being pi. Now, if you, again, this is going to be very difficult to enter in. You can start with this number over here. If you enter 2, then the square root button, and then times 2 equals, you should have 2.828, that's this part here. Then push the square button, x squared, and you get 8. Then times pi times pi equals, then times 45 equals, then divided by 360 equals, and you should get 3.14, that's pi. So you don't have to write the exact answer. You can round off if you prefer. But again, this is a very, very difficult thing to enter into your calculator, so you better get used to doing that. Now, the area of the triangle, we're going to be able to find that actually pretty easily. You could use trigonometry. You could cut this angle in half, find this side with sine 22.5. Half of 45 is 22.5. Then find the height with cosine 22.5, and so on and so forth. But we're going to do it a kind of a tricky way here. We're going to drop an altitude down here, and I drop that altitude down so that we have a 90-degree angle here. That's just the way I drew it. Now, if this angle here is 45 and this angle is 90, well, that means this angle must be 45. So now this yellow triangle is a 45, 45, 90 triangle. Now you might be thinking, well, who cares? How does that help us? Well, that means that we can find the height of this triangle if we consider the blue to be the base. So that's going to help us find the area. If this length here, the hypotenuse, is 2 root 2, remember, our 45, 45, 90 special triangle theorem tells us that if this side is W, then this side is W also, and the hypotenuse is W root 2. So that helps us. You see the 2 root 2 up here? That helps us to find what W is going to be. And so W is also obviously going to be 2. It's that blue 2. So that means the height, this purple segment here, the height is going to be 2. So we know the height of the triangle, the yellow triangle, but we still need to find the base. What is the base? We don't have the base. So it sounds like we just wasted our time because we don't have the yellow segment there, but actually we do, because that's the same length as this length here. That length is 2 root 2 because it's a radius. These two yellow lengths are both radii, so the base is 2 root 2 also. So I know that that seems kind of confusing. If you don't want to use that method, you can just use sine or cosine. But it's going to be 1/2 times the base times height. That's the area of a triangle. And the base is 2 root 2. And the height is, we found, that's W, that's 2. So, I'm going to move this over a little bit. So now we just simplify. 1/2 times 2, that's just 1, so they just cancel out. You're left with 2 root 2. So the hard part is over at this point. The area of the shaded region is equal to the area of the sector minus the area of the triangle. The area of the sector we found is pi, and the area of the triangle is 2 root 2. Now again, you have to be very careful about entering that into your calculator. We're told that we need to round off to the nearest thousandth, but if you enter that into your calculator incorrectly, you're going to get the wrong answer. So I'm going to push the pi button and then minus 2 times 2 square root button equals. And we get, and I should write an approximately equal to sign, we get approximately 0.313. So that's the nearest thousandth place. If you got that one right, good job. If you had problems with that, it was probably because you were entering the numbers into your calculator incorrectly. Every calculator is different, so I can't tell you how to do it for every single calculator, but this is something that you can easily find out yourself. So it does take a while to figure it out, but you need to know how to use your calculator. All right, 2 more problems. If the height of the regular pyramid below is 13 centimeters, find its volume. Round to the nearest thousand. So try 24. When you come back, we'll do it together. Okay, we're back. So the volume of a pyramid is 1/3 times the base area times the height. We already used that formula. Now the height is easy. That's just going to be 13. So it seems like this is pretty easy, but the problem is capital B stands for the base area, right? We have to find the area of this base, and that requires either a very complicated formula, not really that complicated, or it requires us to actually be able to do the math ourselves. Now we could use a formula, but I'm not going to show you that formula because I want you to actually learn how to do the math. Now this is supposed to be a regular pentagon. It doesn't look like a regular pentagon because it's not easy to draw a regular pentagon. But your pentagon doesn't have to be perfect. This is not an art class. So that's the bottom, that's the base if we turn it so we're looking straight down onto it. So as usual, we're just going to divide it up into congruent triangles. They don't look perfectly congruent, but I'm going to take this triangle here and I'm going to find the area of that, and then I'm going to multiply by 5. That's all we're doing here. So I'm going to drop down that height, and we need to find we need to find some angles. Now a total rotation is 360 degrees. Each one of these angles has equal measure. So I'm going to take 360 and divide by 5. And again, you probably know how to do this by now, so you don't really need to watch me. But this angle here, this total angle, is going to be 72 degrees. But I don't want the total angle because I want to deal with the right triangle. So I'm going to take one of those right triangles out and divide 72 by 2, and we get 36 degrees. So that's the angle that I'm going to be dealing with. And now we're told that the side length is 9, so we know that the base of this triangle is 9, and it's an isosceles triangle for reasons that are pretty obvious. I mean, these lengths we know they're going to have to be equal, so we can just divide 9 by 2 and get 4.5. And I know that's kind of a small triangle to analyze, but we want to find the height, the purple dotted line. So we're looking for h, and we're going to use tangent because tangent is opposite over adjacent. We don't know the hypotenuse. So we don't have a lot of time to show all the steps here, but that's going to end up being 4.5 over tangent 36 degrees. I already showed you the steps on how to solve for h on that. So 4.5, actually I might just leave it like that for now. So that's the height, and I'm going to label that part of the problem as height, so we know that that's what that work was dedicated to. Now we're going to find the base. Now it turns out we actually already know the base. The base is just 9. So we didn't really need to do much work for that. We have the base. And so now I'm going to try to make that a squiggly so we don't confuse it with the answers. So the area of each the total area of the base, and I'm going to label that capital B, is equal to 5 times the area of each one of those triangles. And the area of each triangle is 1/2 base times height. The base is 9, and the height is 4.5 over tangent 36 degrees. You can basically just crunch the numbers at that point. We could try to simplify a lot of that, but it's not really necessary. 4.5 divided by 36, then the tangent button, equals 6.19 is this whole blue expression here, times 9 equals, and then divided by 2 equals, because that's 1/2, and then times 5 equals, we get 139.358669. I'm going to carry out a lot of decimals so we don't have round off error. So that's the base area. So now the final part of the problem is to find the total volume. So volume is equal to 1/3 times capital B times H. We know that capital B is 139.358669, and I'm going to keep that in my calculator. And the height we were given in the very beginning of the problem, that's 13 centimeters, the green. So 13. So I'm going to multiply that number by 13 that I still have in my calculator, equals, and then divided by 3 equals. So we're told to round off to the nearest thousandth. So that's going to be 603.888. And the units are cubic centimeters. If you got that one right, good job. Okay, on to 25. Go ahead and try 25. Last problem. When you come back, we'll do it together. All right, we're back. Write a flowchart proof to show that if the quadrilateral below is a square, then its diagonals are congruent. So we're going to start with the given information. A, B, C, D is a square. You can draw a picture of a square there in blue, or you can just spell it out. I don't really care. And that is given information. Now, because it's a square, we know that angle A and angle D are right angles. And that's the definition of a square. So what we're going to do is we're going to draw the diagonals. We have the orange diagonal, and then I'm going to take out that triangle, draw it down here. So that's a triangle ADC. But I'm also going to draw another triangle. We have this triangle here. So I'm going to take the upper triangle out and draw it over here. They should be the same size, but it doesn't really matter. That This is just for explaining what's going on here. So that's triangle ADB. And we're trying to show that the orange and the blue segments are congruent. Now we know that these angles are right angles. We just demonstrated that. We know that this side is congruent to this side because those are both AD. So I'm going to say segment AD is congruent to itself by the reflexive property of congruence. And we can also say that DC is congruent to AB by the definition of a square, because all the sides of a square are congruent. So we know that DC, segment DC is congruent to segment AB by the definition of a square. And so that follows, I need to write that below this first bubble, because that follows from that given information that we know it's a square, and the definition of a square tells us both of these green pieces of information here. So we also need to say that because angle A and angle D are they're both right angles, that angle A is congruent to angle D. Now you can say that they're both their measures are both 90 degrees, use the transitive property of equality, but it's easier just to use the right angle congruence theorem. You need to know the right angle congruence theorem, the congruent supplements theorem, and the congruent complements theorem. If two angles are both right angles, then they're congruent. So that's one of the simplest theorems out there, but you do need to use that. You can't just say that they're congruent without using the right angle congruence theorem. So given all of this green information, we can now say that the two triangles here are congruent. So I'm going to bring this down here a little. We don't have much room because I drew those triangles in our flow chart. So I'm going to bring this down here. I'm going to bring this here and up here to say that triangle ADC is congruent to triangle DAB. Make sure your letters are in the right order. And we know that because we have the yellow and the blue side in one triangle are congruent to the yellow and the blue in the other triangle, and the purple angle in between them, those angles are also congruent. So we know that the triangles are congruent by the SAS, triangle congruence postulate. So now that we know that the triangles are congruent, we can say that the orange side, AC, is congruent to the green side, BD, which is what we're trying to do. That's the whole point of the problem, by the fact that corresponding parts of congruent triangles are congruent. And that's it. So this flow chart is a little bit difficult to see just because we drew all these pictures. You don't need to draw those pictures. It'd probably help. So anyway, that was the class today. Let's take screenshots of all the work that we did to help you with your homework or to study for the test. Remember, I'm going to give you a practice test for homework, so these screenshots are going to help you. That's screenshot number 1 and number 2. Or you can take a picture with your phone. And number 3. And number 4. And number 5. And number 6. and number 7, and number 8. Now don't go before you get your homework. Remember, the homework is a practice test. Here's screenshot number 1 of the practice test. This is version 2. And screenshot number 2. And screenshot number 3. And number 4. And number 5. And number 6. And number 7. And number 8. But don't go before you get the answers. Remember, it's not enough to just attempt the practice test for homework. You need to do it correctly, so you need to check all your answers. Here's screenshot number 1 of the answers and screenshot number 2. So get that practice test done completely correctly and neatly and keep it in order in your binder. And remember, you need to go back and study the second half of the course, everything after test number 3, which seems like a daunting task, but again, your studying is going to intensify right before a test. So I'll look forward to seeing you in the next class when we're going to take part 2 of the final test, and that's going to be the end of the course. We're going to have one more class where we talk about how to assign yourself a score for the whole course and a grade and so on and so forth. But the next class is going to be the end when it comes to the material, so I'll look forward to seeing you in the next class.